Hello everybody, my name is Daniel Morris. Welcome to this webinar about improved software verification and validation in regulated environments. Like I said, my name is Daniel Morris. I'm working with Polarion Software at Professional Services, where I do a lot of coachings and introductions of Polarion. And today I'm joined is Niroshan Rajadurai. Do you want to introduce yourself?
Sure. Hi, my name is Niroshan Rajadurai, and I'm the Director of Sales for Vector Software here in Europe. And I work with a lot of our customers, helping them with verification and validation and continuous integration type aspects of their software lifecycle.
If you cannot hear us, you won't hear what I'm saying, but you can read what's on the screen. By default, you should join the audio broadcast, and you should be able to hear us and listen to us. If you have got some questions, use the WebEx Q&A or chat panel to ask some questions, and we will answer them. Maybe we'll answer them directly by voice, or we will write you an answer in our Q&A panel. And please, if you've got any questions, please address them to all panelists so everyone gets the information. Another information for you would be this webinar will be recorded. So if you missed something during the webinar, it's no problem. We can give you the link to this recording and you can watch it another time, or you can send it to someone else who wants to have a look on this webinar. To start, we will introduce both of our companies, and then Niroshan will tell you about the process we have defined to do this webinar. So we'll start with Polarion. Who is Polarion Software? Polarion Software is an application lifecycle management system. So you can do requirements management, test management, defect management, task management. Everything could be done with Polarion Software. And for this, Polarion has some different licenses. So you've got the ALM, which can do everything, and you've got some other licenses, like, for example, requirements management, which is the red one, or case management, or QA, which is the green one. And these are only a subset of the ALM. So if you are a requirements engineer and you want to do requirements management, you would choose this license so you only get a subset of the features which are only important for you. In the past, when we heard about ALM, we saw there were a lot of islands for different type of users. That managers had their programs, testers had their programs, requirement engineers, developers, everyone had their programs to do their daily work. And it was really complicated to work together. And for this, you had to build bridges to the different islands to work together. Polarion, like I said, is built as an ALM platform, so you can do everything and you don't need to build these bridges. You've got requirements management, test management, change management, everything in it, and it's just because of the license what type of features you will get, and you can combine these. And we've got also some companies like Forrester had a look for ALM, and they think with Polarion is tomorrow's ALM platform, so we are doing a good job. And as you can see, we are working in every kind of industry. So we've got the medical, the aerospace industry, automotive, where we work with, for example, ISO 26262, and we've got templates for it to make your life easier, that you don't have to build your processes at the beginning. You can also use templates to start working Polarion much faster. And of course, Polarion is a web-based solution. So you can access them via web. You don't need to install anything. You could just need a browser and can access to Polarion. Maybe some additional thing about Polarion. At the moment, we've got more than 1 million users. We are strongly working with the open source community. And because of that, we've got so much users which are working with solutions Polarion developed, or Polarion helped developing it. And we've got a strong global presence. We've got our headquarters in Stuttgart in Germany, and we've got a lot of, we've got some offices in the US and France, and we are working with a lot of partners, so we can help you wherever you need us. These are some clients which already work with Polarion, and you see it's not one special type of industry. We've got we are working, for example, we've got the US Air Force, and Fresenius Medical Care, so in the medical industry. You've got some automotive, and they are using Polarion and build their own templates and build their process how they need it for their work.
Okay, so Vector Software. So Vector Software is a company that specializes in developing embedded software testing products. So this is from a very early stage, we decided that this is really where we wanted to focus our efforts and focus our technology. So the company is based in the U.S. and was founded in 1990, and it was actually founded by two embedded developers who were working on an avionics project with Lockheed Martin. In 1992, what they figured was that they could build a product that could automate the software testing process, a unit test automation tool. And so they started working on this in 1992, and in 1994 they sold the first version of VectorCast to Lockheed Martin for the C-130J aircraft, which is a military transport aircraft. And so from there, the technology has grown, and we've, as different standards have come about, we've grown from the aerospace market into automotive, into medical devices, railway, and industrial automation. So our corporate headquarters is in Rhode Island, which is on the east coast of the U.S., and we have several sales and support offices worldwide. So we have the office in Germany near Düsseldorf, the office in London, which is where I'm based, which is our European headquarters as well, and then several spread out across Asia and the U.S. as well. So we have lots of clients. So if you look at the aerospace industry, for example, kind of the who's who there. So we have companies like BAE Systems here in the UK who use us on all their military aircraft and military equipment. We have companies like Honeywell and Rockwell Automation who use us on all of the avionics software that goes in commercial airplanes. So if any of you have flown an airplane in the last 10 years, then you've already trusted your lives to VectorCast. In the automotive industry, this is a growing market for us with the new standard or compliance requirement, ISO 26262. So there we have companies like Valeo, Autoliv, Robert Bosch on the airbags, for example, Hyundai, Fujitsu on the clusters, and so on. Medical devices, again, several companies there. Probably the one that everyone knows about is Philips, who make the portable defibrillators that you see in the airplanes and the airports, or also even companies like Sirona, for example, who have X-ray machines when you go and see your doctor. So just very briefly, so railway, we have companies like Bombardier, for example, that use our tools to validate all of the signaling softwares that go in the high-speed trains that are used in Europe and the London Underground. And then industrial automation, we have companies like Endress & Hauser who use us for their gas and pressure management devices, and companies like Caterpillar who use us as well for their systems, and even British Energy. So typically the customers we have are customers that have some kind of safety or mission-critical application, or they need to be very thorough with their testing, or they need to do unit integration testing, or the ability to automate regression testing. So our solution, so full embedded software testing. So here what we're talking about is being able to do unit and integration testing, and being able to measure code coverage through the cycle, so being able to see directly as a result of your testing what code is being executed and what code isn't being executed, and then being able to do automated regression testing, so not just developing your test cases initially, but as you change your code over time, being able to repeat that testing to make sure that you haven't broken any of the requirements or any of the test cases in the process. Testing on embedded targets and simulators, so actually running those test cases on the real embedded device or the real microprocessor where you're going to ship. So if you're building some kind of workstation system, running it on that actual workstation, or if you're building a device like a defibrillator or a ECU for a car, being actually able to run the test cases on that physical device and making sure that the code works correctly, and also seeing the artifacts from that process. We also have qualification materials, so if you need to certify and you need to show that the tool is acceptable, then we have all this documentation that's available. we look to deliver true embedded test automation. So the easiest to use test tool in the market, that's really the goal. That's how we drive our technology. Support for continuous integration, so working with ALM tools like what Polarion have, and then working with other technology for static analysis and so on, where appropriate. World-class service and support, so highly engineers with a lot of expertise to be able to support you as you have technical issues and work through and make sure that we're able to resolve and advise you based on the challenges that you have for your project. So the benefits of using a tool like VectorCast: reduce time to market, easier certification qualification, and most importantly, verifiable savings of time and money. So it's nice to have a tool, but if it doesn't save you money, then why are you investing the money?
So that's about the process, about the webinar today. We'll show you, we manage our requirements in Polarion, write a specification like you know it and already know it in Word or in Excel. Just write your requirement specification and then export these requirements and transfer to VectorCast.
Yeah, so with VectorCast, what we'll then do is we'll take a look at some of the code that's associated with these requirements, and we'll start building some test cases to verify that the requirements are being met, and then we'll confirm those test cases run correctly, that the requirements are being met, and then we'll push that information back into Polarion so that we can do a full round trip from requirements to test cases back to the requirements, showing the traceability between the two.
This demonstration isn't a live presentation. It's just an example of how this will work. So you would say we are not connected together at the moment. We are just going to show you how it will work. And now we go on and switch to the live demo. So I will start to show you about how to specify your requirements in Polarion, and then we will transfer it to Vector and like the process we've described. So let me switch to our web, and I'll have a look about the chat. Some could connect, and okay, it looks good. Like I said, otherwise we are going to share you everything, and you can see everything and hear everything what we have done. Like I said, Polarion is working in a web browser. At the moment, I'm working with a Firefox. I can also use Chrome or Internet Explorer, for example. And you just need the URL to the server. At the moment, I'm working on my local machine, and I've got a local server. And you can access them via the URL. You've got a login screen, and you use your login credentials, and you access the project you are assigned to. So on the left is the navigation panel, and we always say, okay, this is more for Polarion has also the goal to make it very easy for you. So because if you started working with Word or Excel and you are going to use a tool for the first time, it's really complicated at the beginning to start with such a tool. And so the goal of Polarion is to make it easy, and so that everyone knows to start and where to click. And this navigation bar is, we always say it's more for the advanced users. So if you want to open a specific specification, you click on the key and click on specification, and you can find all the specifications in here. But you need to know where to find it. For this, Polarion has a solution, or has an option, like this was introduced in Windows 7, and I like it very much. In the past, when I wanted to open, for example, Microsoft Word, I was searching for, okay, all programs, Microsoft Office, Microsoft Word. So I was looking in all my folders, where is Word? Nowadays in Windows 7, I just type Word, and I get directly some examples, what is helpful for me. And most of the time, you simply have to press Enter, and you jump directly into the program you want to. Polarion has the same. For example, I'll take this dinner specification, what we are using in a minute. So I just type, and Polarion will find me directly an example, like this dinner document. So it's much easier for me to find. But the goal is to, on the right, you've got the wiki pages, which should guide you through everything. So for example, you're just interested in requirements. Then you click on this requirements page, and you will jump directly into a new wiki page. So you're guided in the tool, and you can see all the process in this project. So for example, you see, okay, we've got already some specifications. There is an example workflow of the requirements, and there are links to traceability parts. So the goal of this wiki page is to guide the user. But now let's have a look for our requirements, for example. We've got a list of requirements already in Polarion. So you see, okay, here are different type of requirements. These work item types can be defined by yourself. So if you say, okay, now we've got with this template, we've got business case, requirement, test case, task, change request, and so on. But if you say, okay, we've got different work item types, it's no problem. You can define them by yourself very easily, and you can define which attributes should be in there, what workflow should be behind these work items. Everything can be defined. So you can build your processes which you are already working for 10 years or some more years, whatever. But let's have a look for these requirements. We had a list of these requirements in here. And that's now the first part where we say, okay, we wanted to use a view the users already know. And for this example, we've got here an Excel table. So we've got our columns. We can define them by ourselves. We can say, okay, we want to have more columns in here. So that's no problem for these columns. And you see, okay, so these requirements are all in a specific status. And this attributes. So let's have a look for the attributes. So you've got different attributes like an author, you've got the project, you've got categories, and you can select multiple categories if you want to. You see, okay, it's an asterisk, so you've got some authority fields, you have an assignee. So all types of attributes can be defined in Polarion, and you see there's some time points, so you can do this project planning in here as well. But now let's say, okay, I don't want to save this, so I press OK, discard changes. We've got a nice list of requirements in here. But if we want to add some requirements, we don't want to do it in a tracker. We used to work on documents. So if we want to work on documents, I'll click on this open document, and all the requirements are in the specification in here. So this is a document viewer in Polarion. See, okay, we've got some headings, a title, some free, and maybe some requirements, and already a template of my requirements. Of course, you can import them from Word or Excel. So if you already have some Word specifications, you can import them as a requirement specification or a test specification. So it's no problem. Or you can start with an empty document and just type the information or the requirement in here. And you can select this, for example, and say, okay, this one is a requirement. And I want this one, for example, as a heading, title of the requirement, so I'll add it in here. And after I save it, I'll get an ID for this one. Or you can say, okay, well, these requirements are below functional requirements, but maybe I want to move them. So for example, I'll say, okay, let's select them, press Control X, and I'll put them below here. So you can move them inside of Polarion and they won't get a new ID. Or you can set physical links that you just go into a requirement, press a tab button, and you will have a hierarchy in here. So if I open this properties panel, you will see, okay, this one, this vector 86 has a parent, vector 85. And if I have a look in this vector 85, it is a vector 86. So just by pressing the tab button, they are linked together. And if I want to add some, I'll just press enter, and it's like a bullet point list. I can simply write some new requirements, and if I press enter another time, I'll just go into the description. But another time enter, it's just like a bullet point list. I will get a new requirement, and so on. And you can, of course, you can jump into the free text mode and write some free text in here. Or what we want to do is, let's have a look. I saved this one. Let's say we've got clearing a table. We want to have a look for the table tree view. So you see all these work item types are in here as well. Tree view, and of course we can do some changes in here. For example, let me say, okay, let's add something to the description. I would say, okay, I'll take an image in here. And let's take this table. If I insert it, it's in the description. All these changes which are made in here are made in this document as well. So it doesn't matter in which type of view you are working. All the changes are in both. It's just a special view. And this view is much easier for most of you who already know Word to just write the specification. And after we've written the specification, we need to export that so that someone can make some changes outside of Polarion, or they review this document. For this, you've got this Word round-trip where you can export your work items. You say, okay, they should review this document, or I would say I'll take this prioritization mode where I want them to change some attributes, for example. So I don't want them to change the title. They should only be able to change the severity, for example, so attribute of these requirements. When I export this one, I will get a Word spec. And this Word spec, I'll open it directly in Word, and you see, okay, I've got my specification, and this one is now read-on. So let's have a look for our table. Here's our table. So we cannot change anything in here. So it's just, they can just the things we wanted them to change. That they say, okay, this is a must-have, for example. And they say, this is a must-have, or maybe this is a nice-to-have. Or they make some comments on here and say, okay, let's say this one is a mandatory requirement, for example. And they save it so they can do all review in Word and can re-import it back to Polarion. So I'll save this dinner spec and re-import it into Polarion. So let me have a look. I want to import my changes, import my dinner spec. It was successful. See, okay, now this one is a must-have. This one is a must-have and a nice-to-have. Well, while we've exported, we need to know which changes were made. Well, because maybe we exported it and sent it to different persons, and we want to see all the changes which were made. For this, Polarion has this history. It compares some revisions of the document, and you see I've got a lot of versions of my document, and I would just want to check the last two changes which were made and want to compare them. And I see which were made are highlighted in here, that I see, okay, this one changed from should have to must have, and here was a comment added. Or and if I want to have a look for which work items direct, I've got this work items compare view, and I see, okay, from these three requirements, I changed the severity. So every changes are tracked in Polarion, and you can always see old states of documents. So if someone, for example, wants to see a specification, how it looked like in a specific state, for example, let's say for the release 1.1, how did our specification look at this release? It's no problem because of the history. You can always see or show an old state of your document. For example, if I show this one, I'll see, okay, now these requirements are all of them do have severity, so it's no problem. So after we specified our requirement specification, like in Word, that's of course only a small subset of requirements management, what it can be done in Polarion, but we want the connection between Polarion and VectorCAST. So now we created our requirement spec, and if I have a look at this test capability table, at the moment we don't have any cases, only these example test cases here, just to show you how this traceability table would look like. So now here you see, okay, we've got the sample 4, which is linked to a test case, sample 3, and maybe we also have this test case has failed once and it already has a defect, and which is linked together. So you see all this traceability part, and at the moment we don't have any test cases for these requirements in here. So now we want to have a look, okay, can we transfer these requirements to VectorCAST so that we can execute and create our test cases in VectorCAST.
So I think everyone can see my Vectorcast window open. So basically, what I'm going to do now is we're going to import the requirements that Daniel has just built for us inside Polarion. So at the moment, we're using a CSV import and export facility, but in the future, this will be more automated to actually use the SOAP interface into Polarion to get the information. So I'll just set up this connection here, and I'll choose my requirements file, and I'll say get fields. So here we have the requirements. So we've imported the headers, and so now we'll just do some mapping between what Vectorcast is going to use to track the requirements and what Polarion has as the labels for the requirements. So just very quickly do this and say import. And so now we've pulled in all our requirements. And you can see here we have a little Python script that acts as the glue between Vectorcast and Polarion. So it's also very easy for the user to customize this if they need to, or if they need to do any special mapping or anything like that. It's fully customizable. So if you have a look at the view here, you can now see all of the requirements that we've imported. So if we hover over any of these requirements, we can see the detailed description for the requirements. So this is useful now, so you don't have to context switch between different tools. Everything is presented to you inside a single tool. So now let's start talking about building our unit test cases. So looking at the requirements that we had before, this is the project that we're working with. So you can see this project has a couple of C++ files, and the file that's of interest to us is manager.cpp. This is a C++ example, but it would work exactly the same if it was C. And here you can see we have a constructor and some functions like adding, or methods like add included desert, place order, and so on, clear table and get check total. So our goal is to unit test this file manager.cpp and build some test cases to confirm the requirements associated with the source file. Coming back into Vectorcast here, we can just get rid of this window for a second. And the working directory is set, so we'll create a new unit test environment, so a C++ environment. And if we bring this up here, you can see the first thing that we need to do is we need to choose the compiler that we want to work with. So we'll say compiler here, and we'll say Vectorcast min.gw C++, just because this is what we're planning to use to start off with. And we'll tell Vectorcast where to find the repository for the requirements. And we'll choose next. Here we'll give the environment a name. So the source file that we're working with is manager.cpp, so I'll just call it manager_cpp_unit_test, and we'll choose next. And here you can see we can choose what kind of testing methodology that we want to do. So in this example, because the source code already exists, we can do traditional unit testing. So this is where the code exists. We build a framework around the code, and then we build some test cases. But we can also do object file testing or library interface testing, and this is where you're actually supplying the Vectorcast framework with the binary that you want to unit test. And typically, if you're a safety critical customer and you need to have some assurance about how the binary is built, then you might look at these. But a typical user wouldn't look at these features. And then finally, we also have support for things like test-driven development. So this is where you're applying things like agile techniques, and you want to actually have your requirements, you want to define your test cases, and then actually write the code and then confirm that the code passes before you sort of do the next step. So Vectorcast can be used kind of in the traditional waterfall methodology and also the TDD type methodology. So anyway, we'll choose next here. Here we can choose to do white box and black box testing. So in C++, white box gives you access to locally into private and protected attributes of your class, and in C it gives you access to locally defined functions and locally defined global variables. Here for the code coverage, we can also choose what kind of code coverage we want to do. So we can do statement coverage, branch, MCDC, which looks at the subconditions inside a complex conditional to confirm each of them independently check for their true or false and the overall side effect of the decision, or we can do combinations of statement and branches, statement and MCDC. Anyway, for now, we'll just leave that empty, and we'll choose next. Here we need to tell Vectorcast where the source files are located. So here everything is in a single directory, so I can just point to it. But if you had multiple directories, you could point Vectorcast to those directories. Or Vectorcast can even analyze your build output from whichever IDE you're using to automatically grab this information. So an important point is in this webinar, we're using the graphical version of Vectorcast. But when you actually come to really using VectorCast, you might find that a lot of these things can be automated using the command line, so you don't have to have the GUI open to do a lot of these things that may traditionally be a little bit more hard work to do manually. So here we'll choose next, and so here we can see the source files that are available to test. So I can pick any one of these source files, and I can tell VectorCast, you know what, automatically stub all of the dependencies for me. So in this situation, VectorCast will analyze the code, analyze the dependencies, and then it will build stubs for all of the dependencies automatically, and it will build a test driver to stimulate it. If we choose none, VectorCast will only build a test driver to stimulate manager_driver.cpp, but for all of the dependencies, it'll actually use the real code. Or finally, we can choose custom, and with custom, the nice thing we can do here is we can have VectorCast analyze the dependency tree for us. And so here you can see manager drivers dependent on database and managers dependent on database. So here we can say, for example, you know what? In this example, let's test manager driver and use the real code for database and stub manager, or you know what? Let's use the real code for manager and let's stub database. So you can build like a custom unit integration environment or something like that. And there are much fancier things we can do with like classes of interest if you have multiple inheritance and so on, but maybe a little bit too much for this presentation today. But anyway, let's choose manager.cpp because that's more interesting. And what we'll say is we want to stub all the dependencies. And now we can say build. So just like that, I've given VectorCast all of the information it needs to analyze the code and build the environment for us. I haven't prepared the code in any way. What I've done is I've told it where the source files are located, what I want to do with the dependencies, and the tool goes ahead and builds everything for me automatically. Should finish building. And so here you can see all the methods that were available inside our function, inside our class that we're testing. So if I open up the original source code, you can see here the constructor, for example. You can see add included dessert. Here you can see place order, for example. Here clear table and add party to waiting list and so on. So all the different methods that are available. So if we take a look at place order here, you can see place order takes three parameters. The first one it takes is a table, which is an integer. The second one it takes is a seat, which is also an integer. And the last parameter it takes is order, which is of a user-defined type called order type. So if we wanted to create our first test case, we can just right-click here and say Insert Test Case. And now you have a little table view that shows you the function or the method that you want to test and the same parameters. So very easy to see here what the parameters are and so on. So if you're a test engineer and you don't know the code, you can very quickly see what the arguments are and how you can populate the values and so on without having to navigate directly through the source code to work this out. So if we take a look at the first parameter table here, we can just right-click and say Properties. You can see here the tool is smart enough to work out what the range of the types are. So if you go from a 32-bit to a 64-bit, or if you're working in the embedded world, maybe you have a 16-bit or an 8-bit microprocessor, VectorCast is smart enough to work out what the range of these types are. And here, for example, you can specify values for your parameters. So you can say maybe like 1 or 12 or 15 or 145. Or you can even say, you know what, set this to the minimum value of the type or the mid value of the type or min -1 or max +1. And the nice thing here is if you set it to any of these magic values, if you change architecture and the ranges are different, the tool will automatically scale this value to be in the new range. So we can do it that way. We can do a range of values. So we can say, you know what, call this from the minimum value of the type going to 1024 in steps of 10, for example. Or we can do a list of values. So we can always have a bit of fun here. So say, let's test this with prime numbers. So 2, 3, 5, 7, 11, and so on, and build up a list of special values. Or you can write user code. So in user code, you can write here any legal C or C++ code. So you can say, for example, int val1 equals 10. And here we can say that table is equal to rand mod val1, something like that. Right? So you can write any legal C or C++ code here, and if you have access to the file system or any other locally stored data or even an SQL database, for example, you could probe the database and get information using this user code. Okay? Anyway, for this example, we'll keep it simple. We'll say table is 1, and today we're going to have lunch by ourselves, so seat is 1. And here you can see order is a structure, so if I expand this here, I can see all of the valid fields in the structure. So again, I don't have to navigate through the source code to work out this information. The tool does this for me automatically. So here I can see, it's like, for example, soup is an enumeration, so VectorCast shows me the valid enumeration, so I can say, hey, let's have onion soup, and for salad, we'll be healthy, we'll have Caesar salad, and for entree, we'll keep with the healthy theme, we'll have some chicken, and for dessert, okay, we've been pretty good with the food so far, so maybe we'll have some cake now and treat ourselves. And then finally, for the beverage, we've been working, so no alcohol today, we'll just have some soda. Like so. But you can even, again, here do things like this and say, set this to the minimum value of the type. And so if you change your enumeration, then VectorCast will automatically scale the value to that range. You'll have soda. And now this is a C++ example, so I need to initialize my class pointer as well, of the instance of my class. I'll just bring this out of the way. And so here you can see, we can even see the attributes inside the class, the member attributes, and because we've got white box switched on, we can even see some of these attributes which are private as well. Okay, so far what we've done is we've specified some input values for our test case, but what we need to do now is specify some expected values. So what we can do actually is let's take a quick look at the requirements here. So in this example, we can look at this requirement FR14, so it says placing an order updates the occupied status, so let's choose that. Placing an order updates the number in the party, so we'll choose that, so we'll double click that. And then 16, placing an order updates the seats order, no, we don't want that one, and we want 17, so placing an order updates the check total, so it'll calculate the bill, so we'll double click that too. So just like that, we've done a linkage now between the requirements and the test cases. And if we scroll down here now, we can look at the stub subprograms to define our expected values. So we could define expected values if we're doing pass by reference, for example, here. But here we can look at update table record, which is called at the end of the execution of place order. And here we can say, for example, that actually we expect the value of table to be 1. So that's satisfying this requirement here. And then here, this is a pointer, so we'll say allocate 1 buffer of this pointer. And if we expand this out here, so we say here, okay, the table should be occupied. There should be 1 person in the party. Here, order is an array. So you can see here, for example, the tool is smart enough to work out what the valid range of the array is. So we want to look at the second element in the array. So we'll say index 1, like so. And here you can say entree, this should be chicken. And then for the check total, if we have a look here, you'll see the check total says that it should be, for chicken, it should be 10. So we can write 10 like so, or we can say anything between 1 and 10 is acceptable, or we can even say set 10 plus or minus 5. And if you're working with floating points, you can even say 10 plus or minus 5% like so. For this example, it's interesting to say 1 to 10. So we'll just save that now, and we can just right-click and execute that test case. So you'll see we've executed the test case, and as a result of that execution, we get something called an execution report, which breaks down the execution of the test case into events. The first and last event is the entry and exit into the function under test, and each sub-event is a call to a stub subprogram. So here you can see place order and the values being passed in, and then here you see the second event, which is the call to get table record, which is a stub subprogram that we're not doing anything with. And then here you can see the third event, which is update table record, and here you can see the actual values match the expected values. Okay, so here you can see that the test case is passed. And then finally here we have the fourth event where we exit out of the test case. So now, if we want to create our second test case, we can just right-click and say duplicate test case. And if we have a lot of common initialization, this is useful because it just copies all the information across. So here you can see, we had the scenario of chicken. And if you want to keep testing this requirement FR17, now we can say let's choose a scenario of steak, for example. So we can choose steak here now as an example. And we'll right-click and we'll say execute. And now we can do a batch execution of the test cases, so several test cases at the same time. So here you can see one test case is passed and one test case is failed. If you look at the time, it's because it's UK time, by the way. So we can look here at the second test case that's failed, but we also get here a test case management report, which is a high-level report telling us what test cases have passed and which ones have failed. And if we look across here, you can see as well, you get a little traceability matrix showing you the test case, when it was last run, the pass or fail status, and also the requirements associated with it as well. So you can immediately tell that requirements 14, 15, and 16 have some kind of issue with them. So if we come back here to the code, we can look at the execution report. And if we scroll down here for the execution report, let's just move this out of the way. You can see here, right, we changed the input value from chicken to steak, but we didn't change the expected value. And the program is realistic, so steak is more expensive. So we can come back to our parameters tree here and scroll down. And if we have a look here, we can change chicken to steak. And then here for the check total, we can either set the value as 14, or if there are any people from the quality assurance team, you might want to close your eyes for the next bit, because we can also set the expected values from the actual results, like so. Okay, so that's actually quite good if you're doing refactoring of code and you want to define your test cases, capture the values, and then change the logic inside the code. Then that's where that feature is actually useful. Okay, so let's switch on some code coverage here as well. So we'll switch on the full coverage. And now let's execute these test cases again. So here you can see now both test cases have passed. And we can quickly see this here as well. And if we just get rid of this, you can see in the reports, we have some coverage information as well. So you can see now we have about 100% statement coverage for the constructor, and for place order, we have about 65% code coverage. And so here, for example, if we tick these checkboxes, we can actually view the code coverage in the code. So you can see the annotated source code with what's covered, what's not covered, and what's partially covered. So if you just to explain the colors, a black line of code is not an executable line of code. A green line of code is a line of code that has complete coverage. A red line of code is a line of code that has partial coverage, has no coverage. And an orange line of code is a line of code that has partial coverage. So only the true or the false part has been taken through the code. And here, for example, if we're concerned with MCDC, so modified condition decision coverage, here you can see a truth table. So here you see the complex expression, here you see the simplified expression, and here you see the truth table explaining all the pairs and so on, so that you can see quickly how to build some test cases to properly test this logical point. Okay. And the other nice thing here as well is if we tick the checkboxes, we can view the code coverage independently, or we can view combinations of them, and so on. And the same thing for the metrics here as well. So in the same way, I can just duplicate this test case again, and this time we can have lobster, for example. We'll quickly check the requirements again. Lobster, it's 18, and set it like so. Okay, so here we've set up some test cases now to test this. But the challenge here, though, is that in place order is that we still don't have 100% code coverage. So if we have a look at the numbers here, you can see we're still at about 78% code coverage. So there's still some additional testing that we can do to improve the code coverage. So this is where Vectorcast have some utilities that can help this process. So here, for example, we can say automatically generate boundary value test cases. So this is where we set the input values of the test cases to be, or the function on the test to be the minimum values of the types, the mid values of the types, or the maximum values of the types. Or we can insert basis part test cases. So with basis part test cases, Vectorcast can analyze the flow of the code and automatically come up with the input values to drive the code down those specific parts. So here you can see, for example, it's driving down the lobster path, the pasta path, and so on. And so here, for example, for one of these auto-generated test cases, we can look at the requirements again and set some additional values if we want to. Okay. The other kind of test case we can automatically create are partition test cases. And this, again, is another form of robustness test case. This is where we drive the input values of the function on the test to iterate between its minimum and maximum values for a set number of partitions, and we do all permutations of this. So the idea here is that you don't set a pass or fail value, but if the test case fails throws an exception for some reason, then Vectorcast will catch that and class it as a fail. So here we can just quickly execute all of these test cases and just confirm that everything is running correctly. And as a result of this, we should also see some improvement here now with the code coverage as well. So if we have a look here, for example, you can see place order now is at 100% code coverage. So that's a big improvement just using some of these auto-generated test cases that we have. So the other thing we can quickly do here as well is we can do some static analysis. So maybe if we want to look at the code and say, how can we improve the testing or the quality of the code? Well, we'll switch on static analysis, and we can just kick off the static analysis on the code. And so here we can now see in our testing window, we can see what errors exist with the code. So here, for example, you can see the annotated source code again, and we can click on this particular line. We can see the different errors. Obviously, you need a slightly bigger screen to use this, but you can see here the particular violation that's occurred. You can see a detailed explanation. So this is doing the MISRA C++ standard. So there's an explanation of what the error is and how to rectify it and so on. So again, if you're trying to improve your code, it's quite good, and it's also a learning tool as well. So as soon as you see there's a problem with the code, you can get an explanation of what it is and prevent yourself from making that same error in the future. So at the end of this, we can produce a report here, so we can look at a full report, and this is probably something that we can put in our software design folder. And so here you can see this is all hyperlinked as well, so you can see the test case definitions and the actual execution results. And then down here you can see the annotated source code again with all the code coverage information and so on. So you can just save this, and this is what you would present to your manager or your supervisor to say that everything is tested correctly. So now that we've finished all this, what we can do is we can export this information back into our requirements tracking tool. So we'll just call this the environment field. We'll call this the test case name, and this will say is the status. Okay, so if I hit export here, this will now push the test case information from what we've done back into whichever requirements tracking tool that we're using. Okay, so the last thing that I want to show you is just before we wrap up here is that if I have finished my testing and I want to save some regression scripts so that I can repeat this, I can summarize the whole environment into a set of scripts that we can use later on to reproduce the results. So if I just get rid of this and bring this up. So here you can see this is what we've built during the presentation. And here are the set of regression scripts that summarize what the tool can do. So if we look here, for example, this is the batch file, which is driving VectorCast from the command line. So here you can see all of the commands to drive it. So again, you wouldn't build one of these files from scratch, but once you have it, it's quite easy to customize and set it up for what you want to do. Here you can look at the environment description file. So here you can see a description of what function we're testing or what class we're testing, what coverage we want, where all the source code is located. And then finally here we can look at the test case descriptions as well. So again, you can see these are all ASCII files, so very easy to diff and understand and even manually edit. So if we look, for example, at the test case we built during the presentation, test.value, name of the environment, name of the class, the function, the parameter, and the value. Test.expected, it's stubbed. Again, the name of the class, the function, the parameter, the subparameter, and the value. So if you wanted to reproduce the results from the command line, you can just run the batch file, and this will go ahead and build the whole VectorCast environment for you from the command line headless. So the idea here is that this is what you will be doing for your overnight validation, and then automatically pushing the results of this back into your ALM tool like Polarion. Okay, so just give this a minute to finish, and then I can hand over to Daniel to absorb this information. Running the test cases there, and so we produce the HTML report. If I double click on that report, you can see here this is the same report that you've seen inside VectorCast during the demonstration. So that's a quick show of VectorCast there, so I'll hand over now back to Daniel, and he can take over the next bit.
So we ended at the test case traceability, and when I have a look at the traceability table now, I'll see, okay, so this one that we get a better overview, we'll see that these three requirements, placing in order updates occupied, placing in order updates number and party, and placing in order updates check total, has now three test cases. These three test cases which were executed in VectorCast. So you see that traceability will be transferred to Polarion, and so the requirement manager knows, okay, we've got test cases and test executions for our requirements. And of course, we will have run where we see that there was test execution outside of Polarion, and the test run created, and the test cases were created. And if we have a look, we'll see, okay, which parts were tested, and all of them were passed in this case now. So results and the test cases are transferred to Polarion, and the test run is passed as well. So you've got a reporting in Polarion as well. And then, well, for example, if we say now we were lucky, everything was passed, so that's really good for us. But if there, for example, were some defects or some test case where some defects created, and then, well, that's the next part of the ALM where we say, okay, let's have a look for some defect management, take these defects, assign these defects to some developers, and for example, so that's just a short introduction that you have a life plan where you see, okay, there are some tasks or defects assigned to some here a requirement engineer, a project manager, and myself as a system administrator, and I have to work on some work items. For example, this defect, and defect, maybe you find some source code which is linked to this defect, and you can outside of here what type of source code was changed, and we see, okay, there's an hello world, and you see now that's a really simple source code, what was changed, we added another hello world to this defect. So that's not the best way to fix a defect. I made a really easy example. So you can see all your source code changes in Polarion as well. If you have some source code to a defect, you can simply link them by copying the ID. And then, well, resulting out of the defect, maybe you want to add another, you will add a change request and add some new requirements which need to be tested, and then we'll start from the beginning, that we create some new requirements, maybe for example a new version of our product, and we will transfer it back to VectorCAST. So you see it a round trip all the time. And well, I think we're nearly over time, so I'll end my part of the mission here too. Okay, now we've seen a small part of Polarion, so we have only had a look for requirement management and how you can create some requirements in Polarion in this document view easily, like in Word. You can also import and export it into Polarion, and there is lots of other things in Polarion, and I think in VectorCAST as well, right?
Yes, that's right. That was a very, very brief overview of technology.
So if we have any questions which are not yet answered, I think I'll see a question in our QA panel. I think this one is, I think that's some for you. So the question is, could you please explain in more detail an auto-generated test case is, and what are the limits?
Sure. So the auto-generated test cases, there are a few different kinds of test cases we can create. The first one is the boundary value test cases. So this is where we look at the function or the method that's being tested. We look at the parameters that method takes, and then we work out the range of those types, and we basically call that method with the minimum values of those types, the mid values of those types, and the maximum values of those types. The other one that we do is the partition test case, and that's kind of more of an iterative test case where we do all possible permutations. So we iterate between the minimum and the maximum values for each of the parameters, and we basically do all the permutations. And you can specify a partition there. So you can say, if you say a partition of 3, for example, then it uses min, mid, and max. If you choose a partition of 5, it uses min, then an equidistant point between min and mid. It uses mid, an equidistant point between mid and max, and then max, and so on. And it, again, does all of the possible permutations. The other two that we do is the basis part test cases. So basis part test cases, so if we recall, there's a measurement called the cyclomatic code complexity that McCabe came up with. So what that code complexity is equal to is the number of decisions in your code plus 1, or n plus 1. That also equals the number of linearly independent parts that exist in your code. So VectorCAST can identify the linearly independent parts in your code and populate the input values of the function under test or the method under test to drive it down those parts. Then the last kind of test case we can create is the MCDC test case, and this is where we do all of the possible combinations of logic for like a complex condition, like if A equals 1 and B equals 2 and C equals 3, we do all of the possible permutations there to verify independently that A has an impact on the decision and has no side effects, B is the same thing, and C is the same thing. That's basically how the automatic generated test cases work.
I've got a question, which could be up for both of us, but I think I will answer it. The question was, in Polarion identifier was vector 78, in VectorCAST it was FR17. Why the difference? This is because this wasn't a live demonstration, like I said at the beginning. So we were working on our local machines, everyone by himself, and because of that we had a difference between the IDs. Because in the future there won't be a difference, of course not. Then we will do an export and an import and automatically, and then you will have the same IDs. Then I think there is a question for you. Is the application limited to C or C++?
The application will work with any C code, any C++ code, and any Ada code, Ada 83, Ada 95, and Ada 2005.
We've got another question, how to get the test result and the traceability between requirements and test case VectorCAST to Polarion. The integration we are working on at the moment, I have to say I don't know
I can answer the question.
How this will be done. Well, then, please.
So basically we're using the SOAP interface that's available in Polarion. So when you saw in the VectorCAST demonstration when we said import, in that example we were importing it from a CSV file, which was a dump of the requirements. But when you say import, once this integration is done, it'll be making, I guess, a SOAP connection to Polarion, and then from that it will import those requirements into VectorCAST. And then once it's finished and you want to export those back, it'll be using the same interface to push those results back. So that's the interface that we'll be using within Polarion to get that working. And we're using Python scripts to write that utility, as I showed you again. And so you'll have full control over those. So if there's certain other fields inside Polarion that are interesting that you want to bring into VectorCAST, or there's additional information from VectorCAST that you want to push back into Polarion, then you have the flexibility to do that. And we can support you in doing that as well.
Last question, I think this is up to you as well. There is a question if Java isn't possible.
Right now, Java isn't possible, but we're thinking maybe in 2013 to add Java support as well. We have a few customers that are asking for it, so it is on the roadmap.
Okay, perfect. The question, or someone is interested in requirements management in Polarion and wants to have a look about a tutorial. We have a lot of tutorials on our webpage where you can see all steps and really steps. So these videos are all about, maximum of 5 minutes, about test management, some about writing specifications, about creating a document, and so on. And of course, we've got some other webinars like this one, where you see much more functionality. And of course, if you missed this one and you were interested in Polarion and the start, or you missed a lot about the VectorCAST part, this webinar was recorded, or it's recorded, and we can give you the recorded webinar, so you can have another look about this. And if you send us an email, we can send you the recording of this webinar, so you can contact us if you want to. And I think it's still an open question. Can VectorCAST interface with other project requirements application or just Polarion?
Yes, it can interface with other requirements tracking tools, all the way from very simple things like CSV files or Excel documents to all of the current requirements tracking tools that are in the market. And even if there's something that we don't directly support, we have that open interface, so it's very easy for the end user to customize it. So even if you have your own proprietary requirements tracking system, you can customize the interface to help with that.
So I would say thank you very much. If there aren't any questions left, I think this was a really interesting webinar. I think that's a real nice solution about VectorCasts, and well, on my point on Polarion as well. And I think this was very helpful. Hopefully you think that it's helpful too. And if you need any additional information, here is a site where you can contact us if you want to send us the webinar or some additional information. Feel free to contact us. There are both, for my case, for Polarion software, there are still a lot of webinars. We do a lot of webinars about some different topics. So if you're interested in Polarion and you want to see more, please join our webinars or contact us so we can do a live demonstration, depending on your requirements of a software tool. How about you? Do you have anything?
Yeah, we have, again, lots of webinars that we're doing. We try and do one every month. We have a YouTube channel as well, youtube.com/VectorCast, where you can go and see lots of different demos and examples and workflows looking on different features of the tool. And again, we have lots of information on our website and lots of white papers as well. So, please feel free to go online and have a look. And if anything has intrigued your interest and you'd like to have a chat with us, then drop us an email or give us a phone call, and we're more than happy to have a chat with you about the technology and how it might be applicable for you.
Okay. Thank you very much, and thank you very much for your attention. I wish you a nice evening, day, morning, whatever, depending on the country you're living at the moment. Thank you very much, and to contact us if you're interested in something.
Thank you all. Bye-bye.